welcome back. In this lecture I will give you an introduction to EV batteries. Batteries can store energy and are used to power a large variety of devices, ranging from micro batteries that maintain the memory of computer chips up to batteries that power electrical cars and stabilize the electricity grid. Batteries that can only discharge once are called primary cells. For example, our well-known AAA and AA alkaline batteries. Batteries that can be recharged are called secondary batteries. For example, which are lead acid, nickel metal hydride, and lithium ion batteries. Batteries consist of positive and negative pole or electrode. In a charged battery, energy is stored in chemical form in the electrodes, which is released as electrical energy when discharged. Vice versa, secondary batteries can be charged using electricity, during which the electrical energy is converted to chemical energy stored in the battery. And an important characteristic of batteries is that energy stored efficiency is very high, mostly more than 90% in lithium-ion batteries. In an electrical vehicle, all the energy needed to drive is stored in the EV batteries. Moving from fossil fuels powered cars toward battery powered cars is challenging. First of all, because of fossil fuels such as diesel and gasoline have a large gravimetric energy density compared to batteries. Because car needs to be light as possible, the battery cannot be too heavy. This limits the maximum amount of energy stored in EV batteries, which itself limits the driving range. Lithium-ion batteries currently have the highest gravimetric energy density of all battery technologies. Therefore, they are widely applied in electric mobility today. Lithium-ion batteries have an energy density close to 250 watt-hours per kilogram, which is still relatively small compared to the energy density of fossil fuels. Gasoline, for instance, has an energy density of 12,900 watt-hours per kilogram. However, an electric engine is roughly 4 times as efficient as an internal combustion engine in converting chemical energy into mechanical energy. Thus, an EV battery needs to be roughly 13 times as heavy as gasoline tank to reach the same energy content. Also, cycle life, which is the amount of cycles battery can be recharged, is an important characteristic as this determines the total life of the battery. The cycle life depends on the operation conditions, including temperature, the charge rate, and the load profile. Safety is a major concern for EV cars, and the safety specifications depends on the chemistry of the battery and its use, for instance including the charge rate. In an EV, many individual cells are combined into a battery pack. For example, Tesla car with 85 kilowatt-hour battery pack contains 7,104 individual cells. A crucial component of battery pack is the battery management system, which monitors the state of the individual cells and manages how the individual cells are charged and discharged. This is vital to achieve safe operation, a long cycle life, and optimal performance. The two most common lithium-ion battery shapes are cylindrical and prismatic cells. Typically, cylindrical lithium-ion cells are used in EV technology as they provide the longest cycle life and high safety standard, and they are cheaper to produce. The disadvantages is that they are less efficient in volume packing of multiple cells, simply because of their shape. However, for cooling of cells, this is actually an advantage. Prismatic cells are more volume efficient, and for this reason they are typically employed in mobile phones and tablets. This is our introduction in EV batteries.